In the last presentation, we talked about the stakeholders. Let us continue to talk about the environment, okay, as well as the platform, okay, for the ecosystem under the Singapore VDC framework. So, environment pertains to the physical facilities needed in order for the collaboration between the different stakeholders. So, enabling the stakeholders to collaborate and work with each other to realize common end goals, that requires creating an environment that fosters collaboration, ease of communication, and data and knowledge sharing. These are some of the key things to think about. Okay, so the collaboration can happen whether it is the people physically located in one place, or they could be physically apart, let's say in different parts of the city, or in different cities, or even in different countries. In production work, for example, model or design development, co-location, that means we prefer the different parties to be located at the same place, okay, is preferable, right? But the key to achieving the same result is open communication, shared working platform, clarity of the deliverables, and the efficiency of the processes, right? But certain tasks such as coordination, planning, problem solving will require physical presence of the decision makers and the key stakeholders to work towards a resolution. That means you need the people that is able to make a decision. Okay, all right. So whether in a construction site or design firm office, there are different types of environment where people come together to work on a project. This may include the meeting rooms, okay, design studios, site offices, okay. Nearly all projects would already have these spaces, but the key is to equip them with the necessary provisions or facilities to enable easier collaboration, better visualization, or more effective production or issue resolution. So different ways to do it. Okay, the best is to have it, face to face in a room. Okay, on a long-term basis. Okay, but sometimes we do it through a combination of a virtual, okay, impromptu meeting, okay, or sometimes on site. Next, we go on to platforms. Okay, platforms. So this include data sharing platforms, and a good example is this common data environment, which I will be talking about in one of the chapters later. Okay, collaboration platforms, project management platforms, and all other tools to share information between the team stakeholders and to improve the collaboration. Yeah. So we try to create a common data environment to establish a single source of information for all project data, and that includes the data in the model. Yeah, and that will avoid duplication and mistakes. We try to share project information, include any type of information, whether created in the BIM model or just the normal conventional data format, right? And this common data environment may include different information environments. So there are different types of platforms. You can have a common data environment, okay, which is an online place for collecting, managing, sharing information amongst the team working on a project. Common data environment can take many forms depending on the size and complexity of the project. Okay, it could be on a project server, it could be on a extranet, or it could be a cloud-based system. Yeah. So you can have collaboration tools and platforms. Okay, includes, but it is not limited to coordination collaboration platform, issues management platforms, design review platforms, and etc. Right. So most collaboration tools integrate common data and model sharing, right? And in terms of construction and field management tools platform, okay, again, it is includes, but it's not limited to, for example, the field management tools, quality defects management platform, mobile maps, predictive analytics for field, okay, mobile progress payment. Yeah. So these two may also integrate common data sharing, but the model integration depends on the type and function of each platform. Yeah. The main benefits of this type of platform is to increase productivity on reporting and documentation, improve communication between BIM to the field, or trailer to the field, or vice versa. Next, we'll go into the third big area that underpins the VDC process in the Singapore VDC framework, which is process optimization. So because the different stakeholders, okay, different groups of people by different companies, they will need to create information, handle information, manage information, store information, and all these are done through processes. So that's why if we can optimize the process, that can actually improve the efficiency of the project delivery. So under this process optimization, there are three sub-areas that we are going to look into. We are going to look into this system called Lean, okay, which is a very well-known system in the manufacturing industry, Lean manufacturing. We are going to look into these production control systems. There are different production control systems that we can apply for our VDC project. And also we are going to look into the process mapping. Okay. So the project team shall endeavor to further improve their current state processes beyond mere digitization, of information and the use of technology. Processes in the industry pertain not only to construction planning and scheduling, but all processes involved from the project conceptualization right through until the handover to the client. From a broader high-level design phase workflow, which include interdisciplinary information integration and handoff, to the more detailed process flows for specific activities such as the PVVC method, okay, of this project delivery, manufacturing, and structural floor cycle times. Yeah, optimizing the processes involve making the process visible, learning to see what creates waste, what creates value, and how to constantly check, refine, and improve. So let's go into the first sub area called the Lean, okay, Lean method. Right, so Lean is a journey that the team can take, okay, to maximize the value, okay, and the value is maximized by eliminating wastes and improving the flow. There are many Lean tools which will be shown in the next few slides available for the team to use, okay, and the slides cover some of them, okay, specifically tools that can help planning and the process involvement or improvement. So the key principles to take note of is that firstly, value can be measured by client requirements and the relevant cost, time, and quality to meet that requirement. Waste come in many forms apart from physical waste on site. To implement Lean, okay, is to learn how to see waste from all processes and from different angles. All steps in the process must flow smoothly without delays, bottlenecks, constraints, or interruptions. Yeah, and we can implement a make-ready process or POO. Okay, strive for continuous improvement. The following are some Lean, relevant Lean principles that will be applicable to the design and construction. Yeah. Also, we try to create value, or we verify and we validate value. Ensure the client's requirement have been captured completely, right? Ensure the requirements flow down to the different team members. We try to eliminate waste, okay? And the type of waste could be all these, defects, overproduction, waiting, non-utilized resources, transportation, inventory, motion, extra processing. And at the same time, we also try to improve flow, or we try to reduce variability, reduce the cycle time, reduce the batch sizes, okay, increase flexibility, select an appropriate production control approach, standardize, use a visual management, design the production system for flow and value. So these are some of the so-called Lean principles. So as far as Lean is concerned, okay, the definition of waste is that the waste is any activity that will consume resources. And by itself, the waste does not create or add value. So you can look at the table here, okay. it defines and gives examples of the types of waste that typically will occur, okay, both on site, okay, and in a knowledge intensive work lah. So obviously a defects is a type of waste, okay. Also you can say there is an error that result in a rework, increase the cost, yeah, and the model or drawing discrepancy could be an example of a defects, okay. On site it could be this punch list and the defects, yeah. Overproduction can also be a form of a waste. Also overproduction means that you are producing something, okay, or either before it's needed or is in too great a quantity, yeah. Also in how to say, in a design work or in a design office, okay, over modeling, that means you put in more details than what is needed, okay, actually is a form of overproduction, right. And on site, okay, overproducing or too early production of let's say precast member or these PVDC components, okay. Waiting actually also is a form of waste, okay, where you could be waiting for parts, waiting for machines, waiting for people, okay. So non-utilized resources also is a form of waste, where you are failing to use the people or the resources effectively, okay. Transportation is a type of waste, okay, unnecessary movement of the product between the different processes. Inventory, okay, storing the product as a result of overproduction. Even motion is defined as a waste, okay, where any movement of the man, equipment, or material that does not add value to the process. And extra processing, okay, work that is not specifically asked by the consumer, also is defined as a form of waste. So in that sense, it allows us to then try to pick up more inefficiency from our processes and then try to remove them when we see, all this as waste. There are many types of lean tools that can be used in the industry to look at the waste and how to remove them, or how to make the process more efficient, as can be seen here and in this slide also. We'll be going through these tools in a little bit more detail in the next set of presentation.